Good morning to everyone. Myself Hemant from Triple E Department. I'm from SRIT College. Today my topic is response of underdamped second order system with unit step. Introduction to second order systems. A second order system is characterized by a differential equation involving the second derivative of the output. These systems are common in mechanical, electrical and control systems. They are used in electricals, mechanicals and control systems. They can exhibit different damping behaviors. The three conditions are underdamped condition, overdamped and critical damped. Definition of underdamped systems. An underdamped system has a damping ratio less than 1 and greater than 0. It exhibits oscillatory behavior with gradually decreasing amplitude over time. The response contains both exponential decay and sinusoidal components. Standard second order system equations. The standard form is this, we can't read, but in this slide we can notice that here slash omega slash n is natural frequency and slash is the damping ratio. The unit step input slash u of t slash is used to analyze the transient response. By this we can analyze the transient response. Step response of underdamped system. The response to a unit step input shows oscillations that settle over time. It is characterized by overshoot, undershoot and damping effects. The response is mathematically expressed with exponential and sinusoidal functions. Oscillations are made here. Mathematical form of the response. The time domain response is slash y of t equals to 1 flower bracket of n flower bracket sq or t1 underdamped 2 double flower bracket. Where is the damped natural frequency? Here we can see in the 7th slide. This is the damped natural frequency. The phase angle depends on the system's initial conditions. Key parameters and underdamped response. Overshoot measures how high the response exceeds the steady state value. It measures the overshoot. This measures the steady state value, how high it will be. The settling time indicates how quickly the response stabilizes. The settle time explains about the quickly the response stabilizes. The damping ratio influences oscillation amplitude and speed of settling. Graphical representation. The step response graph shows an initial rise, oscillations and eventual settling. Increased damping ratio reduces oscillation and overshoot. If the damping ratio increases, the oscillations are reduced. The natural frequency determines how fast the system oscillates initially. The step response graph shows an initial rise. The graph will rise, oscillations and eventually settling. Practical applications of underdamped response second order system. Underdamped response are common in mechanical suspension systems. It is also used in electrical and control systems, but here I am speaking about mechanical suspension systems. Electrical circuits like RLC circuits often exhibit underdamped behavior. We know the circuits like RLC circuits. It also exhibits underdamped behavior. Control system design aims to optimize damping for desired transient behavior. Summary and key takeaways. Underdamped second order system exhibits oscillatory transient responses. The response can be described with exponential decay multiplied by sinusoidal functions. Underdamped second order system exhibits oscillatory transient responses. The responses can be described with exponential decay multiplied by sinusoidal function. Damping ratio and natural frequency are critical in shaping the response. Thank you.